Thank you everyone for coming to Boston. Thank you everyone for hosting us in Boston. Really excited to be here. Really excited to talk about Godot and learn about Godot. My name is Simon. I'm a hobbyist game dev. I do a lot of just game jams and stuff. But then in my day job I do a lot more data science. Have been working a lot with machine learning tools for my whole career, and you know have always been looking for intersections between those two things. And I think the intersections are a lot weirder and harder to find than a lot of people with like a machine learning background necessarily think about. But I think there's a lot in the procedural generation space in game development in particular, where I don't know that machine learning models of any kind make things easier or better, but they make things weird sometimes, and that's something I really enjoy. So this talk is a pretty broad introduction to language modeling, starting with a little bit about Markov chains, getting into some of the more modern transformer architectures that have come up recently, but very specifically transformer models that can run on like a person's computer, not something that needs to run in a giant data center somewhere that like is super powerful and does all kinds of weird stuff, but something that does weird stuff on your computer, because I think weird stuff on your computer is like that's what video games is to me. So this is a pretty broad workshop, starting with a kind of high level introduction, then lots of time to kind of mess around with the wrappers that for these language models. I really wanted to get past there's so much weird stuff with just instrumenting them and setting them up. But I think that like a lot of the fun stuff is once they're set up, actually getting use out of them is kind of hard. But there's some aspects of Godot's resource system and some, I think, often underutilized ways to use typing and kind of schema-based outputs from models to really get a lot of mileage out of them in procedural generation contexts, or at least again do weird things like mileage in some direction, even if it's not a useful direction. Yeah, so at a really high level, what is a language? Like, I think it's helpful to take apart the term language model. Like, what is a model? A model is something that is useful to you in some way, that is not the whole thing, right? A weather model might be a way to tell, if it's going to rain tomorrow, if it's going to rain today. It will be raining every day of GodotCon, presumably, but it's useful to know that ahead of time. So what does it mean to try to model language, right? Because language is a lot of stuff. Like, are you trying to model grammar? Are you trying to model specific types of reasoning you might do with language? Are you trying to model like vague sentiment or vibes? And all of that matters when you're trying to when you're actually trying to build a model of what language is. And I think there's some the recent work on language modeling is very much, well, we want to model everything. We want to put the entire internet into a blender. Like, we want to model all human reasoning and do all that. But there's I think a much that's building on a much older strain of Markov chains, and I think it's useful to start there. So there's this concept of a Markov chain, or a Markov process. Is familiar to a lot of folks in game development, is very similar to a finite state machine. It's something where you have some agent, some decision maker that has a state and makes its next decision based only on that state. No additional input, no additional parameters, and the significant aspect of a Markov chain that distinguishes it from some types of state machines is it makes that decision probabilistically. So a lot of early communications researchers, Claude Shannon in particular, were interested in this concept of if you can, can you take a sentence, can you take some string of language and then tell what the next bit of that is based only on what you have so far, which right off the bat, that you kind of know that's not going to work perfectly for all types of language, because that's not what language is. Language is about communicating something. If you could tell what the next word was, by all the words that came before it, by definition, you almost would never need to say anything. But Claude Shannon puts together this concept of I'm going to take bits of a string and try to predict the next part of a string. So in this example, you can see there's you can look at it one letter at a time, try to predict the next letter based only on the last letter. You can look at it based on the last 2 letters. You can look at it based on the last 3 letters. And it starts to resemble, if you use the frequencies of the letters in the English language, it starts to kind of resemble, looking kind of like the structure of English language, or at least the shape of English language. And then, he kind of realized, he saw this. It was, okay, well, this is creating a lot of nonsense words. What if we just work with words? What if we look 1 word back and try to get the next word? What if we look 2 words back and try to get the next word? And he was doing this all by hand with like books of random numbers and stats on distribution of English text. So like he couldn't look a ton of words back. But he kind of, this was an interesting finding for him, an interesting kind of, okay, this does start to reconstruct bits of grammar. It seems like it should be really hard to reconstruct bits of grammar and bits of English language using only what comes before the next token, but or the next word or letter. But you can get something from that. And that really captivated me when I was first learning about this. And in particular, I really enjoyed just, you can do this now with random bits of language you find. So it's very simple to build a Markov model, and you can kind of put together. So this is just like, I took a bunch of stuff from GodotCon publications and Wikipedia articles about papal conclaves, and welcome to the Godot conclave. It's when I was a teenager, I found all this stuff and found it very charming. There are a lot of people doing the King James Bible and the structure of interpretation of computer programs, and like it comes up with funny phrases. It also is clearly incoherent and is clearly just, this is a small body of text, and really highlights the issue of, if you're just doing this over small bodies of text, if you really just end up paraphrasing, or not even paraphrasing, like literally just plagiarizing what came before. So I think it's interesting. I think there's some small games, roguelike games that use these kinds of Markov chains to generate like weird in-game readable text. But like I said, my background is in machine learning. So I was really excited when like the first transformers started getting big, when GPT-2 came out, because they reminded me a lot of Markov chains, but like a little bit more fluent. But not so fluent that it got boring to me. So you could talk for far too long about transformers. But I think for the purposes of this talk, all that's really important to understand is they're built on kind of the same idea of the Markov chain, of trying to look forward in text to predict based on prior tokens what comes next. So an important word there is token, because it's something that kind of was discovered through a lot of experimentation by a lot of clever people, was that this kind of question that Claude Shannon was asking, that a lot of people have been asking natural language processing researchers over the last century have been trying to say, oh, like, do you want to break down, how do you break down the semantic meaning of words in a productive way? Like, characters don't actually mean anything on their own, but words kind of mean too much. Like, dog and dogs are very related words, but like, if you want to treat them the same in a natural language processing system, then it kind of becomes a weird, you have to do some weird work to get that to work. But those are very clearly related words. And tokenization is just a way of kind of like learning the way to break up the words, instead of kind of having a deterministic system where you try to catch every grammatical rule and everything that makes a word similar. So that was a really important development. And the other important development at a high level is just rather than kind of looking at the whole everything that came before it equally, you kind of have a mechanism to learn, to let the system learn over a large body of text what matters. So in this example, we're seeing some attention activations for what is leading to the word it being chosen there, and what you can see are there are very strong connections to these nouns in the past. So like animal, the animal didn't cross the street because it. So we know it is referring to the animal. This has learned over a large body of text that like when this token it shows up, it should heavily attend to nouns in the past, basically. And all of this is to say that this is an interesting technical development that happened. It kind of operationalized some of this natural language processing in a way that made it very commercially appetizing for companies to pour a lot of money into like gathering huge data sets and training these giant models that they could run in their data centers. That happened. What also happened is a ton of like downstream research consequences of that. So you have the like giant models that are trained on everything, that have everything, that you need giant computers to run. You also have a lot of models that use the same architecture that are often trained on equally nebulous training data, but that you can run on your computer that are kind of similar to what goes into rendering a normal game in terms of their computational inputs, and that now have a lot of enterprise scale investment behind making them work because this architecture is so commercially appetizing to the kind of like hyperscale applications. So that's where I got very excited. We'll be using a couple models in this workshop. Ministral 3 billion is a very small model published by the French company Mistral. It's a little bit old now. It came out, I think, like late last year, early this year. But it's a very small model. It's an open license model, which is important. Not every model that you can freely download you are actually free to use in any way you want. Gemma 3 1 billion. I haven't fully read the license terms of it, but it's not Apache 2 or MIT license. So like, it's a little bit newer. It's a little bit more polished. It's a little bit smaller, which is nice. So I wanted to have it available in this workshop. But it does. It's there's a scale of openness here, right? Whether you can download the model for free, whether the free speech, free beer question of all of these are free beer, but not necessarily fully traditionally software licensed, and that's a huge question. And then one other thing to note: so this was very recently published, so it's only loosely worked into this workshop in any way. But I think it's worth mentioning, especially for I like open source. I like Godot being an open source engine. I think if you're building, if you have any aspirations to build games that incorporate these kinds of methods, then it benefits to think about using open source tools. And there's the Allen Institute for AI is a very interesting organization that is the only organization I'm aware of that trains language models fully transparently, non-commercially. They have an open data set, so you can see exactly what goes into the model. It's all Apache 2 and MIT license. All their training code is open. Everything is open. So it's a really good place both to get stuff, to get models that are permissively licensed, and increasingly are quite good, and also to understand more about how this process works, get behind the scenes a little, and understand some of the trade-offs that are being made when producing these models. Because again, this workshop is going to be mostly about this model is produced, what can you do with it? But some of the questions about how to produce them and the trade-offs that go into producing them are quite interesting. So highly recommend looking into them. And one final note on what these models often it can be really intimidating, like trying to look into like what these models are, what they're made of, what they do. And I think one thing to highlight is the difference between instruction-tuned and non-instruction-tuned models. So in this workshop, we're going to be working exclusively with instruction-tuned models. That means in addition to doing a lot of the next token prediction training, there was also a prolonged process that kind of makes it behave like a chatbot in some contexts, where if you give it instructions, it will kind of by default want to follow those instructions. That's both really helpful in some contexts and really unhelpful in some contexts. So we're going to talk a little bit about how to, get around that characterization-ness, and like really have it be behaving as we want, as a part of a larger pipeline, not as a free floating chatty Cathy. Anyway, so that is far more chatter than necessary. So I think it would be good actually to now get into the weeds of the workshop. So let's start out just trying to get set up. Has everyone been able to either download the OpenAI or not the OpenAI, the API key, or else download? Yes.
So I accessed the tiny URL and I got to the just the link that has the text, but I'm not the API downloading for it.
Perfect. So that should be a file. There should be like if you can download that file as a text file, and then do you have the GitHub scaffold downloaded to your computer?
Yes.
So if you put the API key in the utils folder in there, everything should work just out of the box. So let me. So I think everyone or almost everyone is on is going to be using the remote. So there's a flag in here that's a global flag that's just local, which determines whether you're using something that is actually on your computer or something that is remotely hosted by OpenRouter, which is just a company that essentially provides a common interface to access a bunch of these models, open models, closed models. A decent place if you're looking to experiment. So if you want to set local to false, if you want to load the API key, and then got a mic check file in here that should, if everything goes according to plan. Okay. If folks can open that, try to run that scene and see if it works, and then we'll talk about what's in it a bit. Yes.
Can you bring back the repository? I think I missed.
Yes, of course. Thank me. Thank you. Let me actually. Sorry, that was. I could have picked a shorter repository name. Abbreviations are.
How do you know if it's working or not?
So if it's generating any words at all, it's working. If it says apple, if it says potato, if it says hello, if it says no, if it says yes, like there's just a check to see, is it hitting the API, and is it worthwhile to start? Okay. Oh, I'm sorry. Yeah, let me copy paste this into the GitHub or into the Godot too, so I can. So let me keep this open. Is that visible where it is for folks who need the API key, or is that text too small? Let me just keep it open here. So it's Simon M. Nash / GodotCon Boston 2025 Markov chain with a shotgun workshop scaffold with randomized capitalization throughout. Exactly. It's make sure we're not picking the most likely next token at every stage. Well, folks are just keep an eye on something. All right. Do folks have the repo cloned now, or?
Yeah.
Great. I will start talking a little bit about here. Okay. So, what is going on here? Why is it saying Apple? So right now, this is calling. We have this wrapper function connection manager. If you're curious, after the workshop and or during the workshop, during some of the free periods, you can go dig into some of what that's doing under the hood. But at a high level, this is an interface for similar to a Markov chain, similar to a transformer. It is a thing that you can make requests to. You can add a bunch of context to it, and then you can generate with it. So the significant things are create requests that creates this language model request object. That request object has an add context method on it that lets you just append tons of information, what you want this language model to be aware of, to think about. Well, it's generating text, and then you have this generate call that sends that to the router or to Open Router. Open Router sends it to Mistral. Mistral sends a word back to you. So in this context, there's a couple things to know. So here, add context, generate a random word. Like I was saying, this is an instruction tuned model. This is kind of out of the box built to do what people say. It's built to the company's business model involves making chatbots and stuff. So they want it to behave like a chatbot. There's an implicit argument here that you can see down here when we say hey. We have the second argument user, and so these are two different levels of command essentially. The system level message is that's a more describe at a high level the model essentially treats that and is trained to treat that with a little bit more seriousness, with a little bit more adherence to what that is saying, and then the user tends to be treated with a little less adherence. So if these instructions contradict each other, that's always an interesting scenario. Usually for super small models, it's pretty easy for a user to generate 10 words. We'll see if that, but it's it doesn't care 90% of the time. But especially as you get in bigger models, it can be the difference between those can be really significant. In general, the way these are thought about, system is kind of the at the developer level. What is the stuff that is kind of always constant, versus user is more randomized, more untrusted input, or less trusted input. But yeah, anyway, this is a kind of mic check thing where we're trying to work, just make sure that the API works. Another element here is the temperature. That's another, we'll get into that a little bit more later. You can think about that roughly as a type of randomness, but both, it's essentially, it's a number from 0 to 1. It is, 0 is still not deterministic, and 1 is still not actually random. So there's some interesting ways to use it, and a lot of but in general, in general, it's less important than what goes into the context. And basically, so the way this connection manager works, this is dealing with asynchronous network calls. So we really don't want to, we don't want to wait every time we make one of these requests. So the connection manager has signals on it for completed requests and failed requests. And you can then do whatever you want with what comes back. So you can see, that what comes back from these models is a big list of stuff, like that. There's metadata about the model, a bunch of stuff that we won't get into about, like, different stopping reasons. You can have it generate multiple passes at once. You get statistics about the tokens it used and the tokens that went into it. But the thing we're mostly going to be extracting is the message content, which extract here, we print it. It works out. Okay. Was everyone able to get? Yes.
I had a question.
Perfect.
I saw you place system at the end of the context.
Yes.
I was curious. That wasn't included on the import, so I don't think I properly.
Yes. So running. So let me open up that function actually. So system is the default to this function. Let me open this. So okay. So essentially, the context that we feed into these models, what they expect is a list of messages and people who sent those message. So that should always be one of system, user, or assistant. System is what the developer instructions are. User are messages received from the user, and assistant is text generated by the model itself. So when we call the add context function, it defaults to system, because that's, if we're talking about this in a procedural generation context, we're not talking about people chatting with the models. So like there tend not to be a lot of user assistant back and forths. So it's just a kind of, syntactic thing where, add context, by default, it goes to system. If it's not, if you want it to be something else, then you need to explicitly specify. Does that make sense at all?
Clear as well.
Okay. Perfect. Any other? Yes.
With the assistant, is that something you have to do in order to make it remember what it's saying?
Yes, and that's something that we'll especially get into, because it's interesting. There's a concept called few shot learning that we'll get into a little bit. But yes, you both need to do that to make it remember what it's saying, or you can use it to put words in its mouth and make it like behave a little better. Where it's, if you have, generate something that looks in this shape, and then give it a user request and a fake thing that it generated that you wrote manually for it, and then you give it a request again, it will be better at adhering to that thing that you wrote for it, which is an interesting concept. That's the primary use of using the assistant. Giving it fake memories, exactly. Gaslighting machine learning models is how we get Skynet, and I look forward to it. Anyway, so has everyone been able to open up open up something, connect to some to the API, get it to generate something. Any other questions at this time?
Yeah, I can't get it to work for some reason.
Excellent. I can
Some weird error.
excellent. I can take a look. There's all kinds of weird errors. It could be.
Not exactly. It's true.
So it looks like so you need to download the API key. And did you? Oh yeah. Oh perfect. Yeah. So you put it in manually. So you can, comment out.
Well, that's what they should be like.
Those are running to so I kind of had an ambiguous setup where you should both enter it or you should download it. But yeah, those were yep.
Yeah.
Perfect. Okay. Thanks. Of course. Thank you.
What's slides?
All right. Let me see. I've got a couple slides to talk about temperature, but it might also be better to just get straight into the content, or more of the content. Yeah. Okay. So a really quick slide. This is everything that goes into a language model request here. The context is what we just talked about. That's the list of pairs between, content and who said the content. The model is, whatever model we're hitting. That's a string. We can hit a lot of, different models. We're, again, mostly going to be hitting Ministral 3B, but, if you have spare time at the end of the workshop, there's some other cool models that, we can talk about. Temperature, that's this kind of pseudo randomness. That's this, instead of taking the next, instead of always, you don't always want to take the most probable next step. It's actually, you don't always want to take the most probable next steps. You can have these big trees of probabilities of what the sentence is going to turn into. You can either always select the next most probable token, or you can try to search down the tree to find the most probable sequence. In just generally, neither of those are how humans talk. We do not, language is not structured as a sequence of probable words. And there's some interesting academic literature on how both of these methods just fall flat and don't end up resembling human language. But it turns out if instead of always trying to take the most probable steps, you kind of advantageously sample from the most probable group of steps, that just holistically ends up working a lot better. So temperature is the amount of that randomness you're adding, essentially. And there's some other ways to add that, but that gets into to some different ways. Yeah, there's some other ways to add that, but not in this workshop. Yes, between 0 and 1 for these purposes. Yes. And then, max tokens is just, what is the maximum amount of chit chat you want back from this model? A lot of the time, you can do some pretty cool things with it if you put that really high, but mostly going to be keeping it low in this workshop, just keep generating objects of manageable size, and then response format, which is the very exciting thing that we're going to be talking about shortly. Tools and tool choice are exciting, kind of weird, and we'll only get into that if we have abundant free time at the end of the workshop. Okay, so let's go back into the meat of things. Let's go into shader control. Okay. So now, it's kind of pointless to just generate, the word apple over and over again. Like I said, I'm really excited about, procedural generation, about simulation type games, about whether these smallish models can fit into those pipelines. And that means that I need to generate things other than text, right? Text is great, but text is, just text. It's not game state, it can't interact with game states productively. You can't have the language model cannot by itself be a game. So if you want it to interact with a game, it needs to, be able to output stuff that isn't text, stuff that maps to Godot objects. So this is a short example of how we can use the like we were talking about with it generates a list of probable words or probable tokens that could come next. It doesn't just always pick the next one. Essentially, what you can do as you're serving this model is outlaw certain tokens to make it fit a certain grammar. So it's become very common, kind of de facto standard to use a JSON schema to define this for a lot of the companies that serve language models. So this means that we can. This means that if we can map a Godot object to a JSON schema, we can pass that JSON schema along with our request, and then as the model is generating, it will only be allowed to generate things that fit in that grammar. And this isn't a catch-all. There's some interesting corner cases here that we'll get into, but it does let us do things like, here we have a shader that generates this little planet, and we ask it to generate a planet. We tell it we have a few strings that should be formatted as hex. We have a few colors that should be formatted as hex. We want a description. We want a population. We want a name, and then it makes something and it colors the shader accordingly. As you can see in the writing, it's writing leaves something to be desired. It kind of cleaves on these ideas of luminescence over and over again. I'm always quite charmed by the things these language models fixate on. But I will say, so for some of the longer term projects that I've been working on with this, more context tends to be your friend in these situations where this has been trained over so much stuff. It kind of it really wants to generate something very generic. It really wants to generate the same thing over and over again. But it's also quite, especially the small ones, both the small ones and the large ones, are quite responsive to everything in their context. So you can throw details about the papal conclave in there, and then suddenly it will, start having ideas. It'll start generating planets that are vaguely inspired by the Pope, if that's what you want. Yes, thank you.
So I only have a rudimentary understanding of how this stuff is priced out. Adding more context would use more tokens, no?
Yes, it does. That's a problem. Yeah, no, but that's also a reason. So using more tokens is so there's two ways to there's two kind of ways to address that. If you're using a hosted language model provider like OpenRouter, input tokens generally are less expensive than output tokens, which is valuable for these kinds of things. Partially maybe because that's a predatory business model where they want all your context. They want your details about the Pope. That's also why I'm interested in local models that can run locally, but that does have the consequence of if you construct really gigantic context lengths, then it takes longer to generate the first token because it needs to get through all of that. So that's something I haven't actually played around with on the kind of long context things I'm thinking about. I've been using hosted providers for so I'm not actually sure holistically how much Mistral 3B running on my 2060 would choke on a few thousand words of context. But I will say there is a big difference too between a little can go a long way in terms of the language model isn't going to write anything interesting for you, but it'll read something that you write and it'll sample from it. So if you want to write something interesting, it's that can be an interesting almost I almost think about it as like a renderer for text, right? If like you can look at the text from different angles and it can like kind of smooth out some of the grammar in different contexts or put it in different paraphrases. But yeah, sorry, does that answer? That was a rambly answer.
Yeah, different providers use tokens differently.
Yes.
So that's just something you have to think about.
Yeah.
Okay.
And locally, it takes longer.
Yep.
And then a bunch of other running my mouth. Okay, excellent. So let's talk a little bit about other things going on here. So roughly how this, this is structured kind of like the real work here is being done by this utility function that is converting the planet schema or the planet Godot object to a JSON schema. Something I found to be very very something that I very much enjoyed is working with Godot's. Godot is very very built to the export variables, and like being able to just kind of like set things in the editor is very intuitive to me on resources. I really like that, and that's also been a kind of intuitive interface for me working with language models because if export variables are the things you want the developer to be able to set, then maybe those are the things you want to expose to a language model to set as well. And then that kind of helps you enumerate some set of variables that you might want to send over to be generated by a model. An important thing here is we have this high level instruction, invent a new planet. But a lot of the heavy lifting is being done by this JSON schema. So and that JSON schema includes descriptions of the field. So for instance, it's really important here that we have primary, secondary, and cloud color all returning, please return this in hex, because otherwise, it'll say, light blue is the color. And then Godot will struggle to, Godot won't struggle. Godot will correctly be like, sir, you are mistaken. That is not something you can set the color to. But so an example of how that can break. This actually, okay. So there's a little bit of defense in depth here. There's a little bit of extra things going on. So we removed that from there, but we still have this, we have this planet cache. So that's a good way to talk about. So even despite the fact we just told it generate some colors, it would have been perfectly within its rights to send back red, blue, gray, whatever. It knew to send back hex. And the reason it knew that is because we have this we wanted here to want to that shouldn't have done that. Oh no, that definitely shouldn't have done that. This definitely shouldn't have worked. Okay.
Oh. Had the hex thing in the string, so
Still have the hex thing in the string?
yeah, and the it had generate a hex at the end of it that you did comment on, not just the example.
Oh, thank you. Yeah. Okay. That's
Oh, this job.
It was doing its job. Thank you.
If I may, in your
Yes.
experience, is this is kind of the job interacting with LLM and businesses trying to develop the constraints that you would need? That's kind of better used set LLM?
Yeah, that's my experience is it's a lot of it's a lot of trying to put constraints on it because again, it's just it's a next token predictor, especially these smaller models. Like these go really wild if you just kind of like let them go. So I think a lot of this is about constructing these kinds of, good lord, it's still working. Yeah, like a lot of it is about describing a lot of it, right, you can put in verbal constraints. A lot of it is about coming up with harder constraints and ways to build really technical assurances. So like the being able to add the JSON schema is a huge benefit. I was doing this a lot like last year without being able to add that, just because the provider I was using didn't offer that. And it was terrible because like it was all of this like repeated like, oh well, retry if it doesn't have this field, or fall back on this default thing. I think it's also in this game in a game development context, it's also important to sometimes think about for like this planet generation type thing, do you actually want population to be a randomly distributed thing chosen by, frequency? Or is that maybe something you want to set according to some system, some, actual system you care about that that the player is interacting with in a predictable way? And then send that as kind of a seed of, okay, well, I have this planet population, 100 million. These are, its biomes. Please generate a little bit else about it. Maybe generate, some trade goods it has or something. I think it's really important to think about where you actually want the procedural generation or the LLM to take, or where you want traditional procedural generation or traditional like deliberate game design decision making, and where you want like more free floating vibes based reasoning. Because I don't think you want it everywhere.
Right.
Yes.
Can you talk to a little bit how you generate the schema itself?
Yes.
It's that one. It's the schema function in the schema generator.
Yes. Schema function in the schema generator. Let's go.
So it's this is what you pass in the planet resource.
Yes.
Then it spits out the schema to send to the LLM.
Yes.
Okay, cool.
So essentially what I do, so the reason, the way, again, I really like the export variable as kind of like it feels kind of like an abuse of it. Actually, like I'm not sure that this is a Godot endorsed, use of it, but I really like a lot of there's Python or JavaScript libraries out there like that are well developed for like, oh, please generate a JSON schema for this arbitrary object that has typing. For Godot, that to my knowledge doesn't exist. But export variables are a nice kind of stand-in for that. So what this is you start with this empty schema. You go through is editor prop, should be a so is this this actually might be, there's some abandoned code in here too.
I don't know if that's the right place.
Yeah.
I just
Let me trace this out through the through planet. So get planet. Yep, that is. But essentially, the in practice, what it is. So yeah. So okay. So the property list has all of the export variables, but also has a bunch of stuff that is not stuff that we want the language model to, there's just properties of the that are not like on the, they're not properly of the object as a, or of the resource as like a general, like it's just memory management stuff or whatever else. So you don't want that, but otherwise you want to you want to come up with a map of types as understood by JSON by the JSON schema to the types in Godot. So you have different behavior for colors. You have this you have different ways of handling just different things. But again, at a high level, it's just oh yeah, there was I had some problems with comments in the JSON being malformed. Like it's kind of just messy. This is messy JSON parsing stuff that or the messy JSON parsing stuff I do not fully grasp every element of, but the schema generation is just a way of taking all the variables, mapping their types to Godot objects or Godot types. And yes.
So quick question, so scroll down a little bit more.
Yes.
Are you passing a crop schema on where it says color and text format?
Am I passing the?
You know how you were trying to get it to enroll?
Yes.
Are you passing that part?
I do not believe I'm hitting that here because I think that because this prop schema already has a description. So I think this shouldn't be being hit right now, but I've written a lot of this in the last couple of days. So that's a good question, though. Yeah, that's not.
Okay.
That was a good catch, though. I got distracted when I saw that too because I was like, wait a minute, that's the. Anyway, great. So does that? Yes.
Yeah, but it's how much of this like JSON parsing stuff do you have to redo every time you change models? Like, is this relatively consistent across models, or is it kind of bespoke?
This is a little bit bespoke to the ones we're working with. So we have a type map here. Like anything that's dealing with these types should be handleable, and it should be not, it shouldn't change model to model. But yeah, right. If you want to do something with a vector too, if you'll have to figure out how to parse that. Honestly, reading through, and I was thinking of this as this was something that was kind of on my agenda before the workshop, and then I re-envisioned as well. Maybe this is a workshop exercise that was deliberately unimplemented. Was color as a instead of being a hex string, being an RGB or three floats. But I think there's a lot of ways to do this, and this should be so. This works for both of the types of things I tried to generate with this. I think it would be quite cool to try to generate other stuff with it too. And that should just be great. Yes.
Yeah, I just want to go back to an earlier thing and say that as a statistician, I think sometimes we mistake random to always be uniform random.
Yes.
But there are all kinds of wonderful random distributions out there for generating things like counts or event times or that kind of thing. So, you can look into gamma or Poisson distribution to solve
Yes.
Get much more realistic distributions of whatever you're trying to generate.
Yes. Agreed. And I think that's again really important also with the simulation aspects or the game dev aspects. Like a lot of things you don't want random populations on planets. You maybe want a different distribution or yes. Thank you. Excellent. Timing, is there supposed to be a break, did I hear at some point, or?
After the workshop, I think.
Oh, after the workshop. Sorry, I thought someone mentioned that there would be like a 15-minute break in the middle of the workshop, and I was confused by that. No, I mean, I can also just, but well, I was trying to decide if it made sense to put people to work on something before or after that, but then like the concept of a break. the concept of a break. Anyway, maybe I do. So, okay. So one other thing I wanted to mention in this format, you know, so the other advantage of structuring these as resources is it makes this it makes this you know right it makes it easier to put stuff that you as the game developer have created into the context in a useful way. So for instance here what we're doing is we're not just generating a planet unbounded by anything. We're we have this planet cache attribute that has these planets that I put together. I picked some color schemes for. I wrote a quick thing for, and then so instead of just like writing free text about the universe or whatever that I want this to fit into, I can kind of take this game data and iterate through, add these as a thing that exists. And there's another one of these things. One of these planets had I've mentioned some like sentient whales on it, and then for a while like the model just got very fixated on that. Every planet had some influence of the sentient whales. So like bug or feature, I don't know, but it's that's a fun that's something I've found very fun to because it kind of forces me to think out the game systems a little bit more, think out about what I want to be adding to this, and what I want to be doing here. Also, so another way we can do that, I wanted to touch on how we would add few-shot learning here, because that I think is again quite interesting. So if we wanted to, if there was some attribute of this that wasn't necessarily capturable by type, that wasn't necessarily capturable by the JSON schema, but that wasn't capturable by the JSON schema, but was something we can articulate. So maybe like maybe we want to keep the color a string for some reason, but it's coming back with ruddy brown instead of a hex for that color. We can give it examples of we can give it examples of that. So
We did promise people a break halfway through.
okay, are we this go what time does this go till?
We have until I think 11:30, and it's 10 now.
10 now. We have until 11:30. We start at 9. Okay, we'll finish this up and then take a break before we move to part 2. Great. So few shot learning is it's what we were talking about earlier. Let me actually go to a different branch that will have this pre-written or planets kind of loosely in the context as oh, here's some planets that exist, here's their name, here's their overview, but like there's a lot of context where you might have a ton of data about the planet that you want to throw into the context window, and the way or you might want to enforce some kind of again these aren't deeply strong reasoner models. These are very these benefit from having seen something multiple times if you want them to imitate it. So the way you can approach that, if you want it to really mimic some aspect of your style, some aspect of the content you're generating, then you can kind of put in what you want, what your actual request will be. So generate a new planet, limit to bare bones geography, and then give this thing you have already built that it never built as an example of that. So in this context, it's turning this into JSON. It's just serializing all that in that kind of way. And then it's saying, you did that. What a great job. Like, you're fantastic. And then you do that again, you give it another thing, you say you did that. Like, it's thrilled. And then you say again, give me a new one. And this time you don't give it anything. So it then gives you something back. That's just something that's a really common practice in this kind of machine learning work, or this kind of like LLM integration work. Like, it's pretty useful. It can be it can introduce, like most things, like it can introduce weird artifacts too. Like, if you were to include like kind of just very junky placeholder content, then like it would generate junky placeholder content because that's what you said you wanted. And it can also kind of maybe over imitate what you've done. Oh, this is running on local. Cool. Yeah, and that's how long it takes to generate on like a random laptop with a 2060 NVIDIA card. So it's not unusable, but like not something that something you would have to very much think about in terms of game design for generating one kind of object. You have to think about if you want to cache that ahead of time, or if you want to kind of pre-generate or do something else. Excellent. Any questions? Yes.
Would you mind clarifying again the difference you can expect putting
User system. So that's one of those tricky things because it depends on the model, and most models are very opaque about how they are trained. So it's one of those things where you kind of like, the Mistral API docs, if you read them, will say, system is for developer level instructions. It's for giving the contours of the task that will be being performed, versus user is some very specific request that you expect some immediate reaction to.
Could it be, well, let's
Yep.
GPT, the difference between like using GPT instructions versus like what I'm putting in as a user? It can override set instructions if I'm looking to that, but the system that we got the context is going to adhere to that first.
Yes, I believe so. I believe that's a I believe I haven't used that. I haven't used ChatGPT with instructions, but I think that's how that's implemented. I think those are system messages, and then so yeah. But and a lot of this is a little bit of a this is much more significant in a like prolonged chatty context. Like, then that difference becomes very significant. In my experience, in this kind of procedural generation context, where you're really usually only doing like one shot of stuff, and then you're not maintaining a conversation with it, it tends to be a little bit like they tend to function the same in practice.
So is this assistant tag, like user or system, a different kind of tag that you're giving it?
Yep. So assistant is the tag for the stuff it generates. So when it sends content back, it will it does so with everything, all of these messages tagged with what generated it. So it has in its message history a bunch of stuff about what it did, what you said, and what like the original developer instructions were. In this context, we're kind of tricking it, because this is not something it said. This is something. This is a kind of stateless process from its point of view. The way we're invoking it, we're building the whole context of the conversation we've had, and then telling it to do the next thing.
Okay.
Does that make sense?
Yeah, so it's pulling this stuff not from its history, but because it's wrapped in your next set of instructions.
Yeah, well, and this stuff, it's not even pulling, from anywhere. This is just stuff that we've constructed that then gets it to do something new. Yes.
Is it the nature of these things being so context dependent that you can so easily go from user to system to assistant without the typical conversational state that, like, say, ChatGPT's user is intended to be engaging?
Sorry, could you?
So, like,
Yeah.
with ChatGPT, they're expecting their user to come at the whole system with a certain use case, I guess.
Yeah.
And they can quickly kind of change it into a sort of pseudo system tag if they were doing something similarly. If you went on to ChatGPT right now and said, generate me a random planet, it would do something like that, but as the assistant for the user.
Yes, and that so it would always behave. It would always do something as the assistant. That's actually an interesting case where that gets into the tool calling concept. Yeah.
This is where the opaqueness, like how just hard it is to tell what's actually going on there.
Yeah. Well, and you're right to there. If you look under the hood at like the OpenAI API that they make accessible, like it looks just like this. You can interact with it in the same way. Like it's only opaque. Like the training process is opaque relative to some other. The exact way in which they train in what it means for it to be a system message versus a user message can be a little bit like and even that like opaque, but like they put out the stuff like the model spec that like it's how they intend it to work at least.
Yeah.
But yeah, right.
That's where the documentation is going to come in.
Yes.
That's where their use case is going to be the most apparent, and you can glean something from that.
Yes. Yes. No, I think that makes sense. Thank you. Yes.
So if you fed the planet that it's generating into the planet cache,
Yes.
every time it generates a planet, would it then just like start self-referentially, like every next planet that it generates, it's going to use its own previous history, like a sort of form of memory?
Let's find out. So right now it let's find out with it on remote. So yes, it will use it and to answer your question more quickly.
Without doing that, it's blank slate every time you generate, right?
Yes, it's a blank slate every time you generate. In this specific context, because of the way we're doing things here, we decide on language model adapter request complete, generate all of this stuff and add our new planet to the planet cache, so that next time when we travel to a new planet and it goes to populate the planet cache, it says.
So you're already doing that.
So we're already doing that in practice, like, and that's one of those things that can have wildly different impacts for if you're working with like a tiny model that fits on your computer versus like a ChatGPT or like a giant model. Because those like that is one area where the like hosted models that like you got to run in a data center just kind of are better at like sampling from their context in kind of interesting ways and like forming like nebulous connections between all these things they've generated, versus like this one, it's just like, well, the whales are here too. Like we love the whales.
How does the context window work? Like, is there a context window?
Yes.
Or, okay.
So the way the transformer architectures generally work is there is 32,000 tokens you can feed into Mistral or Ministral 3 billion. That's like that's on the order of tens of thousands of English words. Like tokens get weird again because it's like a learned distribution. There's all these weird complicated problems of like different languages take different amounts of tokens to represent a word. Although I think some of that's like, again, very weird, very nebulous. It's one of those weird things about AI companies that they're like, yes, like you can send us API requests and we'll tell you how much it costs after like we give you the response back. Just like we don't know how many tokens it'll be, which is great. But anyway, so yes, the way a transformer model works is the way it's trained is like that whole context window goes into the model, and if you only have a tiny bit of context, then most of that is just like empty, like space filler. So it's like it's a transformation on that, and then gradually it fills out the context window with its own stuff, and you can keep feeding that back in, and it'll keep growing, and stuff will start dropping out of the context window at the back end. So yeah, context window length is super important. And then it's also there's also just holistic experience is different models. You get radically different. Sometimes they'll have a giant context window, but like in practice, they'll never refer back or look at things in certain parts of their context window. That used to be a much bigger problem than it is now. But that's just another thing to be aware of on that. But yeah, and again, context windows, the more context you have, the more either expensive or high latency the request gets. Does that answer?
Yeah.
Perfect. Any other questions on this? I think I will take a 5-minute break before we go on to this next section, which is again quite similar. Feel free to look ahead into it. I think honestly, I will start talking again in 5 to 10 minutes. But also, experiment around. Feel free to interrupt me. I would very much, I think want folks to get value out of this workshop. So if ignoring me and just playing with stuff is fun, then please do that and then ask me questions. So I will return to this position in 10 minutes. And also feel free to ask me questions while I'm here. I'm just standing around. The rest of this is a lot more freeform, but I wanted to introduce, I guess, one more concept on top of what we've been doing, because there's been, obviously a recurring theme here is, the context window, what you're putting into the language model's field of vision when you're asking it to generate something, assuming that you can get it to kind of behave appropriately over some set grammar, which you usually can to some degree. What do you actually want to give it? What do you want it to do? And I think a lot of the reason that I'm interested in language here, going back to kind of, what are you trying to model when you're modeling language, is that a lot of the time language is itself kind of a loose model of the world in different ways, a very loose model, a very vibes-based model a lot of the time. But if you can model language in a kind of effective way, you can model a lot of things. This is one placeholder slide. So the next section is called simulation. I'm really excited about about what you can do when you're kind of giving some parts of a simulation to deterministic processes, and you're kind of allowing some flexibility of interaction with that simulation based on more, for lack of a better term, vibes-based simulation. This part 2 section, which you should all be able to run, builds a little bit on that last part 1 that has the planets, and you can generate planets, but there's you can also kind of say, given a planet, generate a time lapse, generate some period of time that happens on that planet, and then change the population, the resources, the technology based on whatever the language model thinks should be the development. And I both wanted to highlight this because I think it's useful to the degree of how much is this schema generation actually robust to different object types, and also how much is how might you build context out of multiple types of objects, out of big collections of stuff that are floating around your game in some form or another, that you might want some kind of language-based process to play a role in adjudicating the next step. So right here, this is like the planet, kind of goes on a defines this object, time lapse object, that like the planet sets a bunch of export variables, gives verbal descriptions of what the meaning of these fields are, and then and then can be applied to a planet, and that's an object on the planet where you apply the time lapse. And I think what's interesting here, what I like here is, I think that there's a lot of approaches to this that again kind of seed the entire game to the language model, or give like a really robust like, oh, just just give us a new planet every step. And what I like, I think this is a very primitive example, but like, so this is a case where maybe we don't want, there's maybe not a great game development context that I can think of for like some undetermined period of time passes, right? Like you kind of want to be able to say, well, this is 1 year, this is 10 years, that's the turn length in this, galaxy simulation game or whatever. So you want to be able to set the time deterministically, while kind of letting the model, infer some other things. And maybe you don't want to let the model infer all these things. Maybe you want the population to be dependent on some other variable. Maybe you want to have downstream things that let you simulate more, robust economics or something, instead of just setting these numbers and changing these numbers with time lapses. But I think I think it's a maybe an underexplored area, or at least an interesting area to me, that you can generate different types of objects with language models, and then you can have deterministic interactions between those objects, and that the kind of stepping that forward step after step, it doesn't depend necessarily on this infinitely building context length, because maybe you don't need to feed every event that's ever happened to the planet to the language model. Next time you want to generate a planet, you might just need to feed the state of the planet as is. And it also, is intuitive because it generates things that live in the game state, and that, then by definition, there's some way for the player to interact with them. There's some potential for an actual game there, other than a beyond that. So what this does is, this adds essentially another button. The way this is implemented, as a matter of scaffolding, and as a matter of the kind of utility stuff here, is that each language model is its own, object, because the signal we want to, or is each node, because the signal we want to emit when a time lapse occurs is different from the signal we want to emit when a planet is generated. Again, I found signals to be just a really useful way of thinking about this. Structuring kind of the language model wrapper as a node, and calling out with signals makes the error handling pretty easy. Makes retrying, because language models can fail quite sporadically, if especially if they're hosted remotely by whatever provider is willing to host your language model for the lowest price. It's so being able to retry or do different providers or different stuff is also pretty. I like having the failure signal and the completed signal. But yeah, so I think that's that again. So what this does, we have the same existing planet generation thing on the warp that adds a new planet, generates a new planet, adds it to the planet cache, and then we also add this time lapse function that has a different but very similar type of description. One thing here, I've yet to find a language model that, no matter how little you tell it to talk, it does not want to talk more. It's be very curt in your descriptions, no more than a sentence or two. It still goes on sometimes, but
Is it because they don't know the sentence, right? The conclusion?
yeah, it's really, I don't know. I mean, as you may have observed during this workshop, it's sometimes hard to know when to stop talking. It's that's just a genuinely hard problem.
Is it possible to put like a hard constraint on that?
Yes. So not in this, but you can essentially say, so you can put a hard constraint on how many tokens they generate. I'd actually be very curious. Let me so you can put a hard constraint on how many tokens they generate. Depending on the handling, that can sometimes just end up making them stop mid-sentence, but sometimes like if there's systems of making them like aware of how many tokens they have to generate, and then they can be a little bit more, but that's a little bit more. And then the other way you can do it is you can add hard stop generation things. So essentially stop talking is a token itself. It is like a word to the language model. It's, you say a bunch of things and one of the words you can say is stop talking. And one of the things that the instruction tuning does is really try to like get this to match a certain length, or like an appropriate length given the instruction. So it's possible to define other stop words when you're interacting with the language model. It's possible to say, when you reach a period, just shut up. Like, do not start another sentence. You are done. And that actually can be it's a similar mechanism to the JSON forcing, right? Of like outlaw certain
Decides not to use punctuation.
Yeah, right. Yes, exactly. I mean, you say that, but like sometimes it does that. It's you gotta build those output tokens somehow. It's yeah. A very fun example I've seen of the kind of forcing certain tokens or forcing certain things to improve performance. There was a recent paper that showed that if or it did this process, there were a bunch of clever things they were doing, but one of the things they did was when it was reaching the end of a math problem and it like thought it had the solution, they would force it to say wait and then continue talking, because forcing it to say wait made it like look back critically at everything it had done, because wait is something you say if you were going to like go and say, actually this other thing happened, and that combined with a bunch of other things like made it better at solving these math problems. So like there are clever ways you can there are clever ways you can be really tricky with like what you're how you're interacting with it. That does get into the like how exactly you're structuring these requests with the exact architecture, the exact service you're using to host the infrastructure. Something kind of annoying about OpenRouter, at least in my experience, is like there's supposed to be a model spec, but people don't always host their models with given they don't always return things in a well-formed model spec. So you'll get back malformed JSON. Sometimes you'll get back tool calls formatted one way from one provider, one way from a different provider. You'll be able to define custom stop words for some models, but not for other models. So that's often a reason to either go with a provider, like one provider you really understand, you really trust their infrastructure, or else self-host and really trust your own infrastructure if you trust your own infrastructure. Yes, that was a long sentence about whether or not how the language models know how to stop talking. Great. But I am curious, that was a good question. I want to check if we literally force a very low token count here, can we get it to be even curter? So right now it's generating 578 tokens for this time elapse. Let's see what the this is untested, so let's find out what happens. So language model request, it has max tokens is set to 1024. Let's set max tokens to 256. And this is for the time lapse, yes.
Also, when you have your like r dot add context lines, I notice you're putting different instructions in different function calls. Like you're simulating the history of your planet, your descriptions, know whether a sentence or two is one, and then like your output should be an instance of the JSON object. How are you thinking about like separating the contextic instructions into different function calls? Because like you've got a few different instructions in that first one, and then you've separated for a second one. Like, is there a method to the madness, or?
Safe answer is no. But no. So clarifying a couple things language-wise. So function calls and tool calls are a specific thing usually, or there's a whole, we could talk a little bit about tool calls in a second. But in this context, what our .add context is doing is literally just, it's appending a message. Each of these messages is technically independent in the dictionary. Some providers, some model hosts will essentially concatenate all system messages into a single message. I don't think I have not observed in working on this workshop any really significant difference between multiple system calls that are separated versus one system call that isn't. That's not to say there isn't one, but I haven't seen one. Yes.
Does priority matter in that, the order that you give them? Would it give you different output if you had reverse the order or something later contradicted something earlier?
Yes, almost certainly, but not in a deterministic way, which is like both the thing I find very fun about working with this and also very frustrating. So it's there's no hard rules of the first instructions. These aren't Asimov's laws of robotics where you can't first and then the second and then third unless it contradicts the other. Like there's these are being parsed as natural language and like are going to be adhered to like a kind of person glancing at these instructions and then trying to follow them from memory. Like it's yeah. But order can matter in certain contexts. Actually, one thing that I've noticed, especially for smaller models where order matters a lot, is it can be quite helpful to have, if you're trying to get it to really adhere to a specific schema, it can be quite helpful to have that schema close to what you want to generate. Just generally, it tends to attend very closely to what immediately precedes it. So if I were to throw this, I think this would still work if I threw this JSON schema up here, and also it's technically forcing the JSON schema too. So this shouldn't cause a problem. But if we didn't force this JSON schema, which actually is a fun thing to look at in general, then that might. So this is an example where we are informing it of the JSON schema. We are saying this is the response we would like you to return it as, but we're not making it do anything. And in this context, and this is on the time lapse. Oh, I lost my window. So this is on the time lapse generator. So it'll generate a plan at first. That's all going according to plan. Time lapse, send the request. That was still a correct response. That's nice-ish. But maybe if we jack the temperature up a little bit. But yeah, so I've noted, like, just anecdotally, if you're not forcing, if you're not forcing a specific schema, and if you want it to follow a specific schema, putting that schema close to what you want to generate, especially for smaller models, can be quite helpful. Especially the bigger you get model-wise, like the more they're used to just having giant context lengths, and the more reliability you get a lot of the time. My computer's freezing up. Any questions? Okay, this is excellent timing anyway for, I think it would be, so I'm going to let my computer restart, but I think that, like now would be a good time to get in a little bit to the, to try to modify like either the planet or their time lapse, try to add a new field to it, or go through that, see if you can get it to generate something else. Whatever whatever you're interested in there could be useful. I'd also be happy, if anyone's interested. So I can give a quick example of tool calling when this comes back up. That's basically a way of saying I don't want to pre-fill the model's context with what it will need. I want the model to be able to, given some instruction, come back to Godot and run an arbitrary function in Godot to grab some data from Godot and send that back to the model before it sends me back my thing. It's an interesting thing. Like I think it's interesting, but it's more interesting in big models and with like robust real-time data feeds that they're trying to access. I think it generally for local models, I've found it's pretty inconsistent and doesn't like I tend to rather produce I tend to prefer to curate the context window manually and not like seed all of that over to the model to try to figure out on its own, just because that's spent invaluable resources. But again, it's an interesting subject, so happy to show an example if as well. But yes.
This might go beyond the scope of the workshop.
Perfect.
But say if you're running Olama locally,
Yes.
off the top of your head, do you know if there's a way to save the state to bring back to the same spot?
Save the state of what you are like.
Save the state of the AI or the language model to the hard drive so that when you bring it, say if you're loading it for next time, it'll have remember the same user inputs and what it said and everything.
All of the user inputs will be like every time in the context of this workshop, every time you talk to you send something over to Olama, it's a fresh request. It doesn't remember anything. You're telling it everything it remembers. In general, I think that's the way I think about having it remember things. If you're having a free flowing conversation with Olama locally and want it to remember things, I'm not sure if there's a way to persist that. I'm sure there is, but also
dig a little deep.
yeah, I mean that there's probably a good like off the shelf Olama solution for that.
It's an open license, there's always a hard way.
Right. I mean, right. Olama runs locally on your computer. Like, there's some way to hack together. Like right now, building on this baseline, it would be pretty easy to kind of like hack together a chat thing with Olama that like remembers because if you just pass back what it the conversation of user said this, assistant said this, user said this, assistant said this, user said that, like that is the full memory of Olama. Well, that's like not just good enough, like that is its state, right? Like it is, if you think about it as a state machine, then like that is the state it generates off. Like that, the state is what has been said so far, and like nothing else is part of it.
You could pass the previous conversation history as a system prompt.
Or as a list of user and assistant prompts would be because if you pass it as a single system prompt, then that would be like be confusing to it. But we're in an excellent reboot cycle of my computer. I think I burned my graphics card doing the projecting and Olama at the same time, which let that be a lesson to all of us. Excellent. But no, I think that I'll, as soon as this boots back up, I'll start working through adding something new to the plan, time lapse. But if others have questions.
And I know you kind of want to show it off, but how does a tool script like call a function in Godot?
It's basically the same way that we do the forcing JSON schema, where you go through and you so when you call the in the request structure, so in the language model request, you have the you have these two arguments, tool use and tools. And tools is an array of tools. Tool use is a setting on whether or not you're asking the LLM to, or you're permissioning the LLM to use tools. If you set tool use, so tool use is normally in these examples so far set to none. If you set it to auto or set it to a specific tool name, then it will look in the list of tools you gave it, which is a list of JSON schemas of functions that you have defined that you are trying to permission it to call. So like it'll have a description of the function, a description of the arguments it would need to generate to go into the function, and then it would so then you say you could imagine essentially reformatting the whole planet generation system we've created as a generate tool call, or as a tool use scenario where there is a generate planet tool that is a function that creates a planet that takes all of these arguments. The JSON schema you pass in is it's using the same thing on its end to force it to generate a valid call to this function, generate planet, and then it produces, and then it sends back so you send that message to the language model, and then the language model sends back the arguments that it wants to send into a function and the function it wants to call.
I guess what's the difference between doing that and just calling the function first and then sending it as a packaged schema? Like, what's the use case for like having the model itself say I want to call a function?
The use case is if you want to delegate a lot of the decision making about what functions to call to the language model. So like it tends to be really interesting to people doing like autonomy work, or like if you think about some of the code generation contexts or the code generation IDEs, they really want the language models to be able to like call a tool to generate code and then call a different tool to run the code, and they don't want like the user to have to sit in between and say like, oh, write me the code, run me the code. They want the agent to kind of make those decisions. Again, I think that has some potential interesting applications in game development, because like you could imagine something running in the background, like kind of like saying, oh, there's a player wandering this area, like maybe I should put an enemy there, maybe I should put a building there, maybe there's ways I could imagine it being cool. I think that in general, I originally formatted this talk strictly using tool use to generate stuff, because I thought that, but I ultimately it's more complex than it needs to be, because you need to it's more complex for the simple case of procedural generation than it needs to be, because you need to call the language model with your function, get back the valid function call, send back the data about what you generated, and then like it sends you back like its thoughts on what it did. And if you really want it to generate something and then do something next based on what it generated, like if you wanted to have it generate a planet and then decide for itself how many years to simulate that planet, then that could be an interesting use case. But overall, it's overcomplicated for that scenario. It's a really interesting, and the other reason, different models support it to different degrees. So it's neither Mistral 3 or Gemini 1B hosted on Olama support tool calling. So it would be something where you'd want to use like Mistral 24 B instruct is a pretty good smallish tool calling model, but that's something that can't really fit on a laptop. Like it can fit on a good server, like it's not like the massive one. Like it can fit on a really good gaming computer. But I felt that's a little bit like more than necessarily. Yeah, I'm very interested in that. Sorry, did that answer your question? Okay. We'll see if my computer ever turns back on. It took over. It knew I was gaslighting it, and well, yeah, no, I think it like this computer can be finicky on temperature, and it has this switch between like the NVIDIA graphics or the integrated graphics, and I wanted faster tokens, so I turned on the NVIDIA graphics. But then yeah, for the heat situation for it, it's just too much. It does this for video games too. Okay.
Never totally pressed though. Somehow it was smart enough to know I gotta slow down.
Yeah, the smallest model. Yeah, I put together like something when GPT-2 first came out, which wasn't huge. It was like GPT-2 wasn't huge, but I couldn't figure out how to get it running in Godot, so I put together like this weird Godot project that like put a Python interpreter in Godot, and like it was like, you wanted to play this project, you got to download a Python interpreter. But then it was like, and the only people who played it were like, what? Like what? Like why did I just download this? um, and I think we're almost at time for. I think the next workshop starts at 11:30, so I'm trying to be wrapped up-ish by 11:15. Any final questions? Final thoughts? Ideas? Yes.
Earlier, you mentioned that there was good literature about the non-sequential nature of language.
Good literature. Oh, yes. So I kind of briefly alluded to this. There's a good blog post, and then the blog post cites the good literature.
Yes. That's good.
Yeah. Let me see if Hugging Face. So Hugging Face is a really great company. They do they like host language models. They're like GitHub for language models is their thing. Or GitHub for machine learning. I will find the blog post before I talk about Hugging Face. But yeah, so essentially blog. Okay, so there's this great. Okay. Sure. Yes. So this blog post, this is back from 2020, when kind of exploring these things was still in a fairly early phase. But yeah, so that's where I cribbed this chart from. But so essentially, the language model doesn't produce words, right? It produces probability distributions over words, and like there were all these ways of sampling common words or common sequences of words. But then there's a really cool graph that we got in here. Yes. So when you look at how humans choose words, or like what actual natural language choices, like sometimes they're choosing words with like 0 probability of coming up, right? And sometimes they're choosing with 1. If you're only choosing really frequent words, then you come up with like these really repetitive, samey like things. You just kind of like repeat the same thing over and over again. Like you never say anything novel or surprising. I enjoy walking my dog, but I'm not enjoy walking my dog. I enjoy walking my dog. Because like, if you're trying to guess from the space of all letters and you just said something, then like repeating what you just said is probably an okay guess of like, if you're going to say something, maybe just repeat yourself. But like, that's not how humans talk, or that's not how humans should talk. So yeah, so there's an article cited here on human quality language, and it doesn't follow generation. So yes. Yes.
Are the slides gonna be available?
Yeah, I can send them out. Yes, yeah, I don't know exactly what channel I will use to message those to everyone, but if nothing else, I will be here over the next few days. So if you do not get the slides, you are free to. Yes.
Oh, yeah, no, I was, yeah.
Yep, that's gonna stay up. I am going to expire the Open Router API key, but you know, it's they have a good free tier where like you don't even have to enter billing information, so you can sign up for Open Router, you can try out. You should be able to do that, and you know they have a pretty good free tier. Excellent. Yes.
Wait, oh, sorry.
A little bit at a time, but
You mentioned earlier, you probably want to be really intentional about where you're using the language models versus traditional programmed randomness and whatnot. Like, I'm curious from your perspective, how would you actually use those spreadsheets in real world?
So the way the project that I'm working on that's using this, because I think there's an aspect to language models that's kind of like it's like my interactions with language models feel great, but like they're like dreams, right? Like no one cares about your dreams, right? Like and so like but I think the you know the like I think so much about what's fun about games is like the shared experience and the shared like like if I'm playing Civilization, I'm playing the same game of Civilization that someone else is. So it's I'm very interested specifically in the multiplayer context because I think that kind of brings this kind of like you know you want to be it makes sense to me that there could be a what I am working on, what I'm trying to do is something where like it's a multiplayer tabletop RPG type thing in a very grounded set universe where the language model is not quite a DM, but is maybe like a small helper function system to like a very detailed adventure module type thing. Like it can't create a new adventure module, but it can like run it pretty decently for a multiplayer thing. That's where I like it. I think there's probably some interesting places in procedural generation too. Other places. Excellent. Thank you so much. Wonderful.